Okay, so here are my rules for adding and subtracting irrational numbers. So there's some vocab here that we need to introduce. So let's just pick a random irrational number, 2 times the cube root of 7. Okay, so the different pieces of this, the part underneath the radical symbol is called the radicand. In this case, the 3 that tells you which root to do, this is called the index. And just like we've been doing, the number in front that multiplies this thing is the coefficient. Okay, so again, in 2 times the cube root of 7, 7 is the radicand, 3 is the index, and 2 is the coefficient. So the rule is when we have multiple terms, both the index and the radicand need to match in order to do anything with the coefficients. So let's see that over here. So these first two terms do match. They both have a radicand of 5, and the index is the invisible 2. So we can just combine the coefficients. -3 plus +2 is -1. And then we keep the index and the radicand. So in this case, we keep the square root of 5. Now this plus 4 radical 12 cannot combine with this, because while they both have the invisible 2 as an index, the radicand here is a 12, which does not match the radicand of 5. So this is much as we can do. Well, of course, -1 is really just -5, radical 5. Okay, this middle problem, it looks like none of the radicands match. Here's a 3, here's a 192, here's a 320. But we saw in a previous unit that we can simplify them. We can try to pull out factors from here and move them outside. So this one is done. We can't simplify that anymore because this 3 radicand is a prime number. We're not going to be able to factor anything out of it. So this 192, however, is the product of 64 times 3. And this 320 is the product of 64 times 5. Okay, so why is the number 64 significant? Well, if you calculate 2 to the 6th power, you get 2, 4, 8, 16, 32, 64. Okay, so I can rewrite this. So 64 I just showed was equal to 2 to the 6th power, and this 3 is still left over. So this 64 is also 2 to the 6th power with a times 5 left over. Okay, so again, first term is done. Okay, now this term, this 2 to the 6th power, and then the 6th root of that. So the 6th power and the 6th root cancel out, so this 2 gets to move outside. So I still have a -2 from above from the beginning of the problem, but now I add an extra 2 that I moved from inside. And this needs to stay within the root of 6 because this is not a 6th power. Okay, similarly here I can move this 2 outside because the 6th root and the power of 6 cancel out. But the 5 stays within the 6th root. Okay, so these, well, so 2 times 2 is 4. Okay, so these two now match. We have -3 and then -4, and the radicands match. So -3 minus 4 more is -7. Copy the radicand. And this one, we just bring it down. Okay, so again, these cannot be combined because while the indexes match, the radicands do not. All right, same thing for this one. These all match, but this one may match. So let's just combine what we can first. 2 minus 1 is 1, plus 3 is 4. Oh, no, sorry. So actually I didn't notice these indexes are different. So these two can combine. So we have 2 times the cube root of 6 plus 3 times the cube root of 6. So that's 5 times the cube root of 6. Okay, now over here, they both have a 6th root, but I need to see if the radicand can match. So let me bring this down for now. Okay, 384 is the product of 64 times 6. And again, we saw earlier that 64 is really 2 to the 6th power. Okay, so I've already got a minus 3 on the outside. Because this is equal to 2 to the 6th power, by moving this outside, I get another 2. So again, the 64 is gone now. We used it up when we moved this 2 outside, but this 6 is still left over. Okay, so negative 3 times 2 is negative 6, and then you keep the 6th root of 6. Okay, so bring this down. We have negative 1 of these minus another 6 of them, so that's minus 7 of them total. Sorry, this is a 6, I don't know why I put a 5. Okay, so here's your final answer. Okay, so now you're going to try the multiplication rules on the next page. So to my sub, if you could please pause the video and then resume when the students are ready to see the answers to the next page. Okay, so hopefully you notice that the answers for multiplying irrational numbers. So we saw that we can multiply the coefficients and the radicands separately. But only when the index matches. So that means that we need to avoid multiplying whenever the index does not match. Okay, so let's try these problems down below. So first of all, we see distributive property. So the negative radical 2 will multiply this radical 10. And then the negative radical 2 will also multiply this negative 4 radical 6. Okay, so over here, they both have an index of invisible 2. So we multiply the outsides. Negative 1 times positive 1 is just negative 1. And then separately, we multiply the insides. 2 times 10 is 20. Okay, over here, again, indexes match. Invisible 2, invisible 2. So on the outside, the coefficients, we have negative 1 times negative 4 becomes positive 4. Now we multiply the radicands. The 2 times the 6 is 12 inside the radical over here. Okay, so now we look back to the front page and we see if we can combine them. Right now the radicands don't match, but maybe we can make them match. So 20 is 4 times 5, and 12 is 4 times 3. So square root of 4 is 2. We take a 2 outside. Square root of 4 again is 2. So the 2 joins the 4 over here. 4 times 2 is 8. Okay, so we can't combine them because the radicands still don't match. So this is as simplified as we can get. Over here, so again, we need to use the distributive property. We need to make sure everyone on this team plays everyone on this team. Okay, so negative 7 times 4 is negative 28. Negative 7 times radical 3x. We can't combine, so we just keep it like that. Next we have radical 3x times 4 times positive 4. Okay, and over here we have radical 3x, or I should say square root of 3x times square root of 3x. So 3 times 3 is 9, x times x is x squared. Okay, so the negative 28 has nothing to combine with. These two middle terms do match. They both have a radicand of 3x and an index of 2. So negative 7 plus 4, you've got negative 3 of those things. And over here, well, square root of 9 is 3, square root of x squared is x. So really we should have known from right up here that when you multiply a square root by itself, it cancels out and just gives you what's inside. Okay, so none of these can be combined. This is just a constant, this has a variable, and this has a radical. Okay, so same thing here. We need to use the distributive property. So make sure everything multiplies everything else. Radical 3 times radical 3. So again, square root times itself is the number inside. Okay, so we got to be careful here. We have square root of 3 times negative 5 times the cube root of 5x. So these cannot combine. Again, we said the rule is the index needs to match. Here, this index is an invisible 2. This index is a 3. So you just need to keep them separate. So we put the coefficient first, negative 5. Then we can put the square root. And then we can put this cube root. Okay, so I know it looks kind of weird with two radicals, but we can't combine them. Okay, moving on, we need to do the other multiplications. So same thing, these can't combine. Okay, and then over here, this last multiplication. So the coefficients, negative 5 times positive 1 is negative 5. Then we have the cube root and multiply the insides together. 5x times 5x is 25x squared. Okay, so notice we cannot do the same thing we did over here, because here square root of 9x squared, square root of 9 is 3. But here we're not taking the square root of 25, we need the cube root. So the cube root of 25 is not 5, so we can't do anything with this. Okay, so we can combine these middle two terms because the radicands and the indexes match. So here we have negative 5 of them, here we gain 1, but we're still at negative 4. And then we keep this whole thing. And then this part is separate. Okay, so that's multiplying. Now we're going to look at how to do dividing radicals. Okay, so you're probably going to want a separate sheet of paper for this. It takes more room than I gave you on the paper, so sorry about that. Okay, so so this problem is pretty simple. You can just simplify. Square root of 4 is 2, square root of 36 is 6. Okay, let's take a look at this one. Radical 4 over 2 radical 20. Okay, so as it says at the top, you cannot have radicals in your denominator, so we need to find a way to get rid of that. So I would like to make this number smaller first if possible. So I'm going to keep the numerator the same and keep this coefficient, but radical 20 can be split up to radical 4 times radical 5. So actually radical 4 we can simplify up top. Then over here, this 4, again, it's 2 squared, so we can move that outside to join the other two. And this 5 needs to stay in the radical because that can't be simplified. So 2 times 2 is 4. But then these are both outside of radicals, so we can reduce them. So 2 divided by 2 is 1, 4 divided by 2 is 2, giving us this at the moment. Sorry, forgot about this too. Okay, so this is not our final answer because we still have a radical in the denominator. So how we are going to get rid of it is we multiply both top and bottom. Again, you're allowed to multiply a fraction as long as you do it equally to both numerator and denominator. So we're going to multiply by whatever the radical is, the square root. So you could multiply by 2 radical 5, but it's not necessary. We're not concerned about the 2 here, we're concerned about the radical. Okay, so up top we get radical 5, which is fine. Radicals are allowed in the numerator, just not the denominator. Okay, and in the denominator we have the 2 still there. Then radical 5 times radical 5 turns into regular 5. So this is our final answer. Okay, so let's do another problem. Let's take a look at this one. Okay. So same thing, I want to get rid of this radical in the denominator. So key difference is this time it's not a square root, it's a cube root. So let's pretend I just did the same thing as before. I said, okay, let me multiply by the thing I see in the radical. Do that to both parts. Okay, so inside the radical I have 5 times 5. Okay, but this does not simplify because 5 times 5, I've got 2 5s, but the cube root means I need 3 of them. So what do? I need to get another 5. So I'm going to multiply by this again. Okay, 10 times 5 is 50. The 3 is still the coefficient. Okay, so now here I have 5 times a third 5. So now I can do the cube root. Okay, so again, the 3 is already there, but then cube root of 5 to the third power is just a regular 5. Okay, so this simplifies to okay, so cube root of 50, can we simplify this? So some of you may have been tempted to split it into 25 times 2, but remember 25 has a square root, but we need a cube root, something used 3 times, not twice. So we can stop right here. Okay, so here's the whole problem. Okay, so another type of problem that we haven't seen yet, this one over here, third from the top on the left side. Okay, so we need to get rid of this radical 2 on the bottom. Okay, so don't write this down, but let's pretend we just use the same strategy as before. Okay, I see a radical 2, so I multiply by radical 2 both times. Okay, so the thing is you would have to distribute. Both parts of the denominator get affected. So radical 2 times 5 would be 5 radical 2, and then plus radical 2 times radical 2 is positive 2. So this part turned into a regular number like we wanted, but we created a new radical from over here. So this isn't going to be helpful. Okay, so here's what we will do instead. So let me recopy the problem down. Okay, so whenever the denominator has it's first of all a binomial, two terms separated by a plus or a minus, and there's a radical involved, you need to multiply by something called the conjugate. Okay, so the conjugate of a plus, let's just say radical b, is a minus radical b. Okay, so it works the other way. If you have a minus radical b in your problem, the conjugate is a plus radical b. So basically whatever the sign is, you switch it. Okay, so why does this work? So it looks like I need to recopy this for a third time. Okay, so in this case, our denominator is 5 plus radical 2, so the conjugate will be 5 minus radical 2. Okay, so let's put it in parentheses so we don't get confused. Okay, numerators, again, we need to distribute. 5 times 5 is 25. 5 times negative radical 2 is minus 5 radical 2. Okay, the denominator, we have a binomial times a binomial, so we need to apply the distributive property. So 5 times 5 is 25. 5 times negative radical 2 is minus 5 radical 2. Okay, positive radical 2 times positive 5 is plus 5 radical 2. And then positive radical 2 times negative radical 2. So positive times negative is negative, but then radical 2 times radical 2 is regular 2. Okay, so the key thing is if you look at these middle two terms, they cancel out. Negative 5 radical 2 plus 5 radical 2 goes away. Okay, so, and we can simplify this part. 25 minus 2 is 23. And we just keep the numerator. So here's the final answer to this problem. Okay, so all the other problems on this paper are similar to these three that I just worked out for you, so you should be able to do them now. So as always, I'll post full solutions on Canvas for you to look at later. So just remember that I'll be checking for this entire packet to be completed when I get back on Tuesday.